into STUDYHIGH.Pk and subscribe, keeping contact for more videos and update. Today we are going to start our next lecture, chapter Carbohydrates, lecture 4. In this lecture, we will discuss the sources and physiological significance of disaccharides and reducing sugar. First of all, I want to inform you what we have discussed in last lecture. In lecture 3, we discussed the different types of glycosidic bond, how you can interpret that whether a monosaccharide is in alpha configuration or beta configuration. We have discussed the different rules on the basis of which you can determine that whether a monosaccharide or glycosidic bond is in alpha configuration, beta configuration. We have also discussed in last lecture the glycosides is different types, C type, S type, N type, etc. And also inform you about cardiac glycosides, the structure of cardiac glycosides, the sources, how they can increase or decrease the heart rate and its cardiac output. Today, first I wanna inform you the learning outcomes of this lecture. After completion of my lecture, what are the important concepts you will come to know about, important diseases, you will understand their sources, causes, diagnosis, treatment, etc. The first, the most basic thing that you will understand is the sources and physiological or biomedical importance of disaccharides. The second important concept is reducing sugar, recognition. We will also solve some MCQs in this topic. Then the concept you will understand are the diseases like sucrose intolerance and lactose intolerance. These are the most important disaccharide related diseases, clinically very important. We will discuss what are the causes of these diseases, how you can diagnose that whether a patient is suffering from sucrose intolerance or lactose intolerance, what is the method of diagnosis, and what you will suggest so that patient can feel better or overcome all these diseases. Then difference between lactose and lactulose. Lactulose and lactose both are disaccharides. What is the difference between them? And what is the clinical significance of lactulose? Lactulose is helpful in treatment of constipation, and how it works or how it can treat constipation. We will also discuss it. Why deficiency of disaccharide disease, the enzymes that involve in hydrolysis of disaccharides in our intestine results in diarrhea and flatulence. Like the symptoms of fructose intolerance or sucrose intolerance is diarrhea and flatulence. The symptoms or signs of lactose intolerance is also diarrhea and flatulence. So what is the cause? Why all disaccharide disease on their deficiency result in diarrhea and flatulence? We will also discuss this concept in detail. Whole lactulose is helpful in treating hepatic encephalopathy. This is a disease which can treat by using our disaccharide lactulose. We will also discuss it. Clinical significance of Trihalos. Why maltose intolerance is very rare. You will listen about in many times in your clinical life about sucrose intolerance, lactose intolerance, but maltose intolerance is very rare. Why this is very rare and persons mostly do not discuss, doctors or patient, most very rare disease, and mostly you will not read it about it in your books, your clinical books, etc. We will also discuss why maltose intolerance is very rare in our clinical life. Why ketones also give positive tests with tolerance or Bentix reagent. Mostly tolerance or Bentix reagents. In chemistry you will study, may have studied in your intermediate classes that tolerance and Bentix reagent react with aldehydes and helpful in recognition of aldehyde group in any compound. But ketones also give positive test. Why? As in our lecture number 2, I inform you about pentosurium. Because of deficiency of L-xylulose reductase, there is a high L-xylulose reductase in urine, but this is a ketonic form of pentose, L-xylulose. It also gives positive test, and doctors mistakenly taken it as a patient is suffering from diabetes mellitus. But pentosurium patient has no relation with diabetes mellitus. So ketones also give positive test with bentix or tolerance reagent. Why this happens? We will also discuss it. So this is the learning outcomes of this lecture. Now I am going to start our first topic of this lecture, the reducing sugar. Any sugar that can act as a reducing agent can denote its proton to any other agent or element like copper that or silver etc. So is known as reducing sugar that can act as a reducing agent. All monosaccharides are reducing in nature, whereas some disaccharides, some oligo and some polysaccharides are also act as a reducing agent. Why they act, we will also discuss. The first basic thing that any sugar which can act as a reducing must have if monosaccharide, then all monosaccharides are reducing in nature because they have a free aldehyde or ketonic group, whereas in disaccharides the basic condition which is necessary for its reducing nature that at least its one anomeric carbon should have free hydroxyl group. So as a result, this sugar can act as a reducing, can reduce something. Whereas those compounds like in sucrose, the anomeric carbon of both glucose and fructose combine with each other and form a glycosidic bond. As a result, both hydroxyl group of anomeric carbons are bound with each other as a result of glycosidic bond. As a result, there is no reducing nature performed or given by sucrose. That's why the basic condition necessary for an disaccharide to be act as a reducing agent is that it must have a free hydroxyl group that is connected with anomeric carbon. We will discuss in detail. First of all, I want to show you the some important concepts. How disaccharides act as a reducing agent. The first, here the disaccharide. It is consists of an anomeric carbon of first part. It connected with the carbon 4 of an other monosaccharide through a glycosidic bond. But the anomeric carbon of this monosaccharide that is connected with other monosaccharide forming a disaccharide has a free hydroxyl group. What will happen when it act as a reducing agent? It changed its configuration. It got converted into from cyclic to acyclic form. Like here you can see it broke its bond with oxygen and form a aldehyde group. As a result, this aldehyde group after its formation can give a reducing, it can act as a reducing agent and act as a reducing sugar. So in this way, disaccharides those have free hydroxyl group connected with anomeric carbon first change their configuration or first got converted into a cyclic form and form a free aldehyde group that can further act as a reducing agent. So it is not the hydroxyl which is donating electron and giving the sugar or reducing nature, but it first converted into aldehyde form, acyclic aldehyde nature, and then this aldehyde group react with the any reagent, tolerance reagent, etc. Similarly, who ketones? These are the ketones. So ketones can also act as a reducing or give positive test with tolerance reagent, but it is not the ketone who give positive test, but ketones for first got converted into aldehyde like disaccharides. So ketones through tautomerization process first converted into aldehyde, and this is the aldehyde which gives positive test with tolerance reagent or Bentix reagent, Ferrin reagent, etc. Here is a simple example showing you how aldehydes can act as a reducing agent. They provide its electron to the any copper and element silver etc. So as a result of this reducing nature, the compound that is acting as a reducing agent converted into its carboxylic form. Like here you can see this is aldehyde. After providing acting as a reducing agent, it is converting into carboxylic acid. So the aldehyde group of the monosaccharide is oxidized into carboxylic form or acidic form. So this is the basic process how monodisaccharide is converted into or acting as a reducing agent or reactive with different tolerance reagent or whole tolerance reagent. So tolerance test, aldehyde converted into carboxylic group as a result. Oh, ketones first converted into aldehyde form, then they further convert aldehyde, and this is the aldehyde which gives positive test with a different type of reagents. Now we will solve some MCQs in this regard. So we discussed those disaccharides whose glycosidic bond formed between the aromatic carbon are non-reducing, like sucrose. In sucrose, the aromatic carbon of glucose and aromatic carbon of fructose both connected with each other, and their hydroxyl groups are not free. That's why sucrose is non-reducing. Similarly, Trihalos. It consists of two glucose molecules, both connected with each other through their carbon 1 hydroxyl group also bound in trihalose. That's why trihalose is also a non-reducing sugar. It cannot reduce any fillings or Bentix reagent. Isomaltose can. So if someone asks you MCQs which of the following is a reducing sugar, so both sucrose and trihalose are the famous non-reducing disaccharides, whereas other disaccharides, maltose, isomaltose, and similarly lactose can act as a reducing sugar. Why? Because they have a free hydroxyl group connected with aromatic carbon, and inshallah we will also discuss it in our coming discussion of this lecture. Now we are going to start our next topic, sucrose. Here is the structure of sucrose. The first, you must know that what are the constituents of sucrose that involve in formation of sucrose. First is the alpha glucose. Why it is alpha glucose? If you remember your last lecture, how you can determine whether a sugar is in alpha form or beta form. So this is the glucose because its carbon 4 is projecting downward, hydroxyl group. It's a carbon 1 aromatic carbon. Its hydroxyl group that is involved in forming glycosidic bond is projected downward, whereas according to rule which we discussed in lecture 3, whereas the carbon that is furthest away from the aromatic carbon is projected upward. Both are in transform, that's why it is alpha glucose. Where this is the structure of group fructofuranose. Here it's carbon number 2, aromatic carbon. Its hydroxyl is projected downward, whereas the carbons away from this, the furthest away from this is CH2OH. It is also projected downward. So both are in cis form. That's why this is a beta fructose. If you remember my last lecture, you must know that how you can determine alpha and beta configuration of different type of monosaccharides. So if someone asks you what are the constituents are on hydrolysis, what is the product of sucrose, it will be one alpha glucose on hydrolysis and second is beta fructose, not alpha fructose. You must remember that only beta fructose involved in formation of sucrose. Second, it is the carbon 1 of glucose and it is the carbon 2 of fructose. No, we are showing the numbering of carbons in forming glycosidic bond. So it is the alpha 1 2 glycosidic bond present between glucose and fructose that are involved in forming the structure of sucrose. So it is the 1 and 2. You must also know which type of glycosidic bond present between the constituents of sucrose. It is alpha 1 2 glycosidic bond. You must also know it. So sometimes in paper, in your MBBS prof examinations, examiner asks, draw the structure of sucrose. So you must take care about this structure. This CH to OH must be drawn downward. OH, positions of different groups. You must know about the positions of different groups that is involved in forming fructose, glucose, etc. Now we are going to start our next topic of sucrose, the sources of sucrose. If you are going to become a scientist, or if someone asks you, please bring some sugar or sucrose, so you can only give or extract if you know where sucrose is present. So sources are very important. First, it is present in beet, as you can see. This is a bead and sugar sucrose is emitting from it. So it is not, it's a crystalline form, just an image. So you can obtain sucrose from beet, sugarcane, sugarcane crops, sorghum plants. So these are the major sources. It is also present in some other vegetable as well, but beet sugar and cane sugar is the famous sources of sucrose. Now we are going to discuss the major clinical related disease of related to sucrose is the sucrose intolerance. It is because of a deficiency of sucrase isomaltase enzyme. Maybe it is genetically not produced, or if produced, the produced enzyme may be partially or totally non-functional in our intestine. So as a result, this may cause sucrose intolerance. If some person eats or drinks sucrose, this sucrose may not be hydrolyzed into its component. As a result, this sucrose may pass into our large intestine and cause diarrhea, flatulence, etc. What are the major symptoms of this sucrose intolerance? Diarrhea. Why diarrhea occurs? We will discuss it in our next slide. Hypoglycemia. As you know that sucrose consists of glucose and fructose. If sucrase enzyme is not present, sucrose will not be broken down and will not yield glucose. As a result, low glucose means hypoglycemia and headaches. Why it results in headaches? Our brain use energy only in the form of glucose. If hypoglycemia occurs, there will be headaches because our brain is not receiving its nutrient in the form of glucose because of hypoglycemia. To how you can diagnose that a patient is suffering from sucrose intolerance or not. Now we are going to discuss it because this is very important. How you can determine a patient is suffering from sucrose intolerance? There are two methods. First of all, use an endoscope. In this method, a hungry patient, you will give just consider here is a glass of sucrose, where sugarcane or any sucrose molecules are present. This is a hungry woman. You give this sucrose to this woman, and after some time, through an endoscope, you take some thing or some nutrient or constants of intestine. So after some time, you interpret or you diagnose that whether the sucrose this woman drink or take in is digested or not. If the sucrose is digested, then you can say that the sucrose has been digested, so sucrase enzyme is present. If the sucrose this hungry woman takes or eats or drink is not digested by the sucrase enzyme, so you can see that sucrose will be present intact in the intestine after some time. So there is a deficiency of sucrase enzyme. There is another method. The sucrose, just think here is the sucrose. It consists of a carbon, that is a carbon 13 isotope. So this carbon 13 isotope help you in determining whether a patient is suffering from sucrose intolerance or not. Like if you want to diagnose it, its method is very simple. You give a woman or any man as well a glass of sucrose. This woman after eating the or drinking or etc anything taking in the sucrose, we then after 30 to 2 hours, 30 minutes to 2 hours, we take all the exhale all the, because this sucrose after going into its digestive system will be digested. Glucose is further through a process of glycolysis, and the final products of the digestion will be carbon dioxide and water. This carbon dioxide will be emitted through the lungs. So the emitted carbon dioxide, if contain carbon 13 isotope, then we will say that the sucrose that this woman has taken in 2 hours or 30 minutes ago has been digested and converted into its products through a different respiratory process. If the carbon dioxide the woman is emitting or exhaling after 2 hours does not contain carbon 13 isotope, which is present in sucrose molecule, then we can say that sucrase enzyme is not present. So it is a concentration of carbon 13 isotope that help you in determining what is the concentration of sucrase present in our body or patient's body, etc. So these are the two methods that are helpful in determining whether a sucrase isomaltase enzyme is present in our human body or not. Now we are going to discuss why sucrose intolerance, lactose intolerance, all these result in diarrhea and flatulence. Because if a patient is lacking any disaccharidase enzyme that involve in digestion or hydrolysis of disaccharides, what will happen? The disaccharide will not be absorbed into our intestine. This disaccharide will pass into our large intestine. Just think this is large intestine. In large intestine, a disaccharide is not hydrolyzed. It passes into our large intestine. In large intestine, this is also more. There is a blood vessels containing water, or osmotically there is high potential in the blood vessel or the surrounding of large intestine. Whereas this just consider here is a large intestine in which this disaccharide that is not digested by our small intestine got entry into large intestine. What will happen? The blood vessels or the water present in the blood vessels surrounding the this large intestine will pass into here. Like you know that water move from high potential to low potential. If a high potential water present here, it and a low potential here, and there is some hole in these two glass, water will pass from this section to this section. In that way, similarly, if sucrose or any disaccharide is not digested and passes into our large intestine, it has low water potential as compared to the blood vessel surrounding the large intestine. Blood will pass from this section into our large intestine. As a result, diarrhea will occur. So this is the basic reason why diarrhea occurs in disaccharidase deficiency. Why flatulence occurs? Large intestine also consists of different types of bacteria. As you can see, Enterococcus, different types of Clostridium, SPP, bactericides. So these bacteria take in disaccharides and causes the fermentation of disaccharides. As a result, produces carbon dioxide, methane gas, different type of gases produced by the bacteria. So these gases causes the flatulence. So this is the process that any disaccharide that got entry into large intestine causes the movement of water from the surrounding blood vessels or the surrounding environment of the large intestine into the lumen of large intestine. As a result, diarrhea occurs, and because large intestine also consists of different types of bacteria that further causes the fermentation of these disaccharides that got entry into our large intestine. As a result, what happens? There is a large production of gases, and gases cause flatulence. So this is the process why deficiency of any disaccharidase enzyme results in diarrhea and flatulence. Now I further want to elaborate this in our next slide. Like here you can see, this is a lactose, inactive lactase. Lactase could not be broken down each lactose into its component galactose and glucose. What happened? This is our undigested lactose. It passes into large intestine and bacteria causes fermentation of it and causes the production of gas. Whereas gas produced by bacteria, but in case of lactose, some fatty acids like lactic acid or acetic acid also be produced by the fermentation of bacteria that we will discuss in lactose intolerance it as well. So this is the cause how diarrhea and flatulence occurs in sucrose intolerance. Now we are going to discuss our next topic, the lactose. The lactose intolerance is the most common clinical disease related to the disaccharides that you will face many times daily life. First, I want to elaborate the structure of lactose. Here is a lactose consists of galactose and glucose. This is the galactose. Why? This hydroxyl group on the carbon 4 is projected upward because galactose is the epimer of C4 epimer of glucose, as I informed you in lecture number 1. Whereas this is the glucose, the aromatic carbon of galactose form a bond with the carbon 4 of glucose. Galactose always in beta form, where glucose may be in alpha or beta form, it does not matter. So these two monosaccharide galactose and glucose combine with each other through beta 1,4 bond, beta 1,4 glycosidic bond. So if someone asks you which glycosidic bond is present between the galactose and glucose, so it is the beta 1,4 glycosidic bond present between these two constituents. Further, so this is the structure of lactose, and it is also a past MBBS prof SCQs in which they ask draw the structure of lactose and inform us about lactose intolerance. So you must know the structure of lactose. So whereas sources, milk is the major source of lactose. Milk and milk dairy products are the sources of the lactose. So this is the commonest and major source of lactose. Now we are going to discuss its further topic. Lactose intolerance. Symptoms: diarrhea, abdominal pain, nausea, vomiting. Same like you listen about in sucrose intolerance or fructose intolerance. What is the causes? Lactase enzyme is involved in digestion of lactose into its component, or involved in hydrolysis of lactose into galactose and glucose. Because of the deficiency of lactase enzyme, there will be no hydrolysis of lactose in small intestine. Lactose will pass into large intestine, will cause diarrhea, flatulence, abdominal pain, nausea, bloating, etc. So hypolactasia, there are the two different types. In some patients, just consider this is the patient. In some patient, there will be low lactase formation. Lactase is present, but low hypolactasia. Alactasia, completely absence of lactase. So if those patient who is suffering from alactasia, they will show the symptom even drinking a small amount of milk or a little lactose. Treatment. So first we want to show you the or explain you the cause of lactose intolerance. In chromosome number 2, there are two genes, LCD gene and MC-M6 gene. These two genes control the lactase production. MC-M6 gene, soon after the birth of the baby, causes the activation of LCT gene. Both are present on chromosome number 2. As a result, what will happen? Lactase will form, and the baby that drinks the milk from the mother can be able to digest the lactose because of lactase formation by this gene. Thousands of years ago, this M6 gene undergo a mutation. As a result, what will happen? Lactase enzyme continue to produce whole life. But these are the genes that control the lactase formation. And this gene causes the activation of this gene. In some patient, because the mutation does not occur in MC-M6 gene. As a result, after some years after the birth, patients stop producing the lactase enzyme. Non-lactase enzyme, lactose intolerance, simple thing. But in most patients, mostly in Africa, Asia, the mutation occurs in this gene. As a result, persons continue to produce lactase enzyme throughout his life. So these two genes involved in controlling. If this gene or this gene could not express itself, there will be no lactose and lactase intolerance. So what you will suggest to the patient? If a patient came to you and said that I am suffering from lactose intolerance, and there is a first you must know, I am going to show you that how you can diagnose that. The simple and very easy method. This patient, you want to study that whether it is suffering from lactose intolerance or not. Give him a glass of milk. If this patient is suffering from lactose intolerance, after drinking this milk, just think this patient has drank it. After drinking milk, in 30 to 1 hour, he will show symptoms of diarrhea, flatulence, abdominal pain, nausea. Then you can easily diagnose that patient is suffering from lactose intolerance because after drinking milk, this patient is not able to digest it or hydrolyze it. So this is the simplest method to diagnose whether a patient is suffering from lactose intolerance or not. Second, if a patient is continuously or suffering from alactasia, hypolactasia, then you suggest him that stop taking lactose in diet. Or if you want to take milk or anything that contain lactose, also take supplement or tablets of lactase enzyme. So this is the two things. Before eating or drinking lactose containing diet, he must take the tablets of lactase supplement. So he will be able to digest temporarily the lactose he drink or eat, because he also take lactase enzyme doses. So this is the treatment, not the permanent treatment, because those patient who is suffering the genetic defect, he could not be able to produce lactase enzyme. So they must, first thing, they must take diet with less lactose, and second thing, if they want to take lactose containing diet, they must take lactase supplements before or after eating lactose. Now we are going to discuss our next topic, maltose. What is the structure and sources of maltose? First, I want to show you maltose obtained from malt. Where are the structure and sources? There are two types of maltose on the basis of the glycosylated bond. This is maltose consists of glucose, and this is another glucose. Both glucose connected with each other with alpha 1 for glycosylated bond. As this is a NMDCAT carbon 1, carbon 4 of second glucose, both connected with each other through 1,4 glycosidic bond. So alpha 1,4 glycosidic bond is present between the two maltose. Is this maltose can act as a reducing agent? So this can act because this is the NMDCAT carbon of 1 glucose. It has a free hydroxyl group. On treatment with tolerance or failing reagent, it can be opened into acyclic form, and further it can react with tolerance or failing reagent and act as a reducing agent. So this is a reducing sugar of disaccharide. In some cases, this is a glucose 1 of maltose, glucose 2, both connected with each other with alpha 1,6 glycosidic bond. So this is the second type of maltose. Only these two forms are present. Now I want to show you that why I have also tell you in initial learning outcome that we will discuss why maltose intolerance is very rare. Because for digestion of sucrose, we have only one enzyme, sucrase. For digestion of lactose, we have only one enzyme, lactase. Whereas for digestion of maltose, we have four different types of maltase enzyme. So if one enzyme is deficient or could not be produced in the body, we have three other types that can digest the maltose. That's why maltose deficiency or maltose intolerance is very rare in patients. So that's why we do not waste our time on maltose intolerance, because this is a very rare disease. Now we are going to discuss the structure and clinical significance of lactulose. First, what is the difference between lactulose and lactose? As you know, lactose consists of galactose and glucose, whereas this lactulose consists of a galactose molecule connected with glycosidic bond with a fructose. So galactose and fructose combine with each other to form lactulose. So if someone asks you what is the difference between lactose and lactulose, you can tell them that lactose consists of beta galactose and as well as alpha glucose or beta glucose, whereas lactulose consists of beta galactose as well as beta fructose, not an other thing or glucose, both connected with each other through glycosidic bond. And what is the structure? It is present on this carbon number 4 of fructose. So how it helps in treating constipation and hepatic encephalopathy? Now I am showing or explaining this how it can cause hepatic useful in treating hepatic encephalopathy and constipation. The first thing that is helpful in treating constipation, And patients suffering from constipation can take the tablets of lactulose, and this is helpful in treating constipation because lactulose is a disaccharide. First thing, second, it is a non-absorbable. It is not be broken down into its simple its constituents. It could not be hydrolyzed by our human body. If it is not hydrolyzed by our human body, this lactulose will go into large intestine and will cause the osmotically movement of water from the surrounding environment of large intestine into the lumen of intestine. As I explained you in our previous slides, what happened? There will be diarrhea, but no diarrhea. Patient is already suffering from constipation. So this the small doses of lactulose will helpful in treatment of constipation. Second thing, in colon, first thing this is a large intestine colon. It is also fermented by bacteria, different types of bacteria. As a result, what will happen? Now I am going to explain you how this lactulose help in treatment of hepatic encephalopathy, in which there is a high concentration of ammonia in the plasma that also affect kidneys, brain, our muscles, etc. So lactulose help in controlling or decreasing the amount of this ammonia in our plasma. Now I am going to explain you how lactulose helpful in controlling the amount or involved in decreasing the ammonia concentration in our plasma. In our large intestine, this lactulose will be fermented by different types of bacteria. This is lactulose. These are the bacteria. They ferment this lactulose and produce a different type of fatty acids like lactic acid and similarly acetic acid. So there is the production of lactic acid as different types of small acids. As a result, the pH will be decreased. There will be a high concentration of hydrogen ions in the colon of large intestine. High concentration of hydrogen ions, what they will do? They will form a bond with ammonia NH3 and convert it into NH4 positive. This is NH3 which can be absorbed from our large intestine, whereas this high concentration of hydrogen ions convert this NH3 into non-absorbable form NH4 positive. This NH4 positive could not be absorbed into our bloodstream, is a non-absorbable form and is less toxic than NH3. In this way, this lactulose is helpful in controlling or decreasing the amount of ammonia from our plasma so that our different body organs could be safe from it. In this way, this lactulose also helpful in treating the hepatic encephalopathy. So this is the basic concept. So there are two important functions that you must know. Lactulose is involved in treatment of constipation, and second, lactulose also involved in treatment of hepatic encephalopathy. Now I am going to discuss our next topic, Trihalos. Our last topic, Trihalos. What are the sources of Trihalos? Then I will show you the structure of Trihalos. Its sources of fungi, as you can see, yeast. These two are the sources of Trihalos, and different type of insects. Hemolymph. Insects hemolymph consist of Trihalos and also contain Trihalase enzyme. Our humans also contain Trihalase enzyme. As a result, they can digest the Trihalose into its component glucose. So first I want to show you that what is the structure of Trihalose. These are the sources like insect hemolymph, similarly fungi, yeast, and these are the sources of Trihalose from which you can obtain Trihalose. Now I am going to show you the structure as well as the clinical significance of Trihalose. So this is the clinical significance that I will show you soon. This is the structure of Trihalose. Trihalose consists of two glucose molecules. So on hydrolysis, like maltose, it yields the maximum amount of glucose. So these two glucose molecules are connected by two NMDCAT carbons, and there is a no free hydroxyl group that can act as a reducing agent because the both hydroxyl group that connected with NMDCAT carbon are involved in forming glycosidic bond like sucrose. So Trihalos is also a non-reducing sugar. One thing. Second, it consists of alpha glucose, and this is also alpha glucose. Why this is alpha glucose? Because in this CH2OH group projected upward and aromatic hydroxide downward, both are in transform, and those monosaccharides in which hydroxyl group connected with aromatic carbon and CH2OH group that is furthest away from this carbon are in transform or alpha. Similarly, this is also glucose and inverted form. This is also in alpha form. Why? In aromatic carbon, the hydroxyl is connected, is projected downward, and the carbon that is furthest away from the aromatic carbon. As I explained you the rule of alpha and beta configuration in lecture number 3. And this is the carbon 6 that is the furthest away from the aromatic carbon. It is projected upward. Both are in transform. That's why this is alpha glucose. Both connected with each other through alpha 1,1 glycosidic bond. This is a structure of trihalose. It can be digested by humans because humans also contain trihalase enzyme. Now I am showing you the functions of trihalose in our medical life. Trihalose along with hyaluronic acid, which is the gas, which is the next chapter which we will discuss. Hyaluronic acid, hyaluronic acid and trihalose both are used in production of artificial tears. Like in films, most you see that the hero is crying, showing tears. That tears are artificial. So you must not be emotional. On the tears, they are showing you because trehalose is involved in their tears. This is also used in those patients who are facing the dry eye or some if you want that patient must cry, then trehalose plus hyaluronic acid. Both are ingredients that together can be used for the production of artificial tears. This is the medical use of trehalose that a number of films has been used and will be used in our future. So today what we have discussed, the first of all today I inform you about trehalose, its medical importance. Second, I have also discussed about the different types like lactose intolerance, lactulose, how it can treat constipation and hepatic encephalopathy. We have also discussed the structure of lactulose, what is the difference between lactose and lactulose, why it causes acidity of colon, because bacteria broken down into free fatty acids like lactic acid and other things. Source, heating milk, source is the lack of lactulose. Heating milk give rise to lactulose. Whereas we can also be synthesized in laboratory by isomerism of lactose, because lactose consists of galactose and glucose. The glucose is isomerized into fructose and we get or we converted that lactose into lactulose. Maltose, its sources, why its maltose intolerance is very rare, because we have a different types of maltase enzyme. Lactose intolerance, we have also discussed it. Its causes, which genes are controlling lactose intolerance, we discussed. Treatment, how you can a patient is suffering from lactose intolerance, we tell him that decrease, please take that diet that will has less lactose in their diet, or take lactase tablets supplements before taking the diet that contain lactose. And symptoms, lactose structure. So how disaccharide deficiency results in diarrhea and flatulence, we discussed it. Sucrose intolerance, its causes, we have also discussed how you can diagnose that by taking small supplements from the small intestine, and C13 stop also involved in diagnosis of sucrose intolerance. Sources of sucrose structure, we also discussed how reducing agents, how you can know about that whether a sugar is reducing in nature or not. This is the today's lecture. In next lecture we will discuss the different types of polysaccharides, their clinical importance, everything it is. So hope you have learned something from me. Please like, share, comment. Thank you very much. Allah Hafiz.